Welcome students to lesson 22 of the natural hazards topic. In this lesson we begin to explore the causes of climate change. We will focus today on the natural causes of climate change, those that are not caused by people. Please write the date, title and learning objective. Have a pen and paper ready to learn. Time to review prior learning. Write 1 to 16, read the paragraphs and put the words in the gaps. Go for it. Okay, let's do this. Greenhouse, number 1. 2. Carbon dioxide. 3. Short wavelength light like ultraviolet. 4. Infrared. 5. Between those degrees Celsius. 6. 21 centimeters. 7. Ice. 8. Thermal expansion. 9. Ice core samples. 10. Pollen samples. 11. Fossil records. 12. Average. 13. Precipitation. 14. Global. 15. Precipitation again. And 16. World. Give yourselves a mark out of 16. If you got 14 or more, you've really mastered these questions. If you got below that, then watch the previous 2 lessons again and then attempt these questions after you've done that to see if you've improved. To introduce this lesson, I'm going to show you a photo of the sun, and a question will appear next to it, and I want to see if you can use your understanding that you already have to answer the question. So there's the question. What do you think might be the answer? And we'll discuss it. So you should have said, if the sun became hotter for whatever reason, this would cause the Earth's climate to get warmer as well, which may lead to a number of different effects on precipitation. It may lead to drier climates in some places, but it may also lead to more precipitation because you have more evaporation of the water due to the higher temperatures. So, in this lesson we're going to be exploring the natural causes of climate change, one of which has to do with the sun, but all of which have to do with the way the Earth and the sun interact. So, I'm going to show you those ideas today, and you need to be completely focused because these are difficult ideas. So, let's go. Here's a picture of the world. It's been flattened out to show you everything on one page, but it shows a physical picture of the world, all its continents and oceans. And around the middle goes the equator. Subtitle and underline it, please. The key message from this picture is to notice that more than half of the land on Earth is in the northern hemisphere. In fact, 2/3 of the land on Earth is in the northern hemisphere, with only 1/3 being in the southern hemisphere. That's really important because it affects the climate on Earth. In summer, we get warmer temperatures because the UK is faced directly towards the sun, and in winter we get colder temperatures because the UK is angled away. Now, because of the way that the land warms up and cools down faster than the sea, the fact that there is more land in the northern hemisphere affects the Earth's climate when the northern hemisphere is pointed towards the sun or angled away. Let me show you how. The first natural cause of climate change is the way the Earth goes around the sun. We call this Earth's orbit. Now, the orbit, the way the Earth goes around the sun, changes in 3 specific ways, and this affects the climate on Earth. Please write the subtitle and underline it with a ruler. There are 3 ways the Earth's orbit changes, and these changes happen in cycles. In other words, every certain amount of years, the orbit changes from one shape of orbit to another shape, and this causes climate change. The first way the Earth's orbit changes is called eccentricity, orbital eccentricity here. And this change takes 96,000 years for it to happen, and here's how it happens. The Earth's orbit around the sun is typically a circular orbit like this. However, Over time, over a period of 96,000 years, the Earth's orbit changes from a circular orbit to a more elliptical orbit like this. And when the Earth's orbit is more elliptical, there are bigger differences between the amount of energy the Earth receives from the Sun, between the time when the Earth is closest to the Sun and whether it's further away, than when the Earth has a circular orbit. The big idea that you need to know is this. The Earth's orbit changes from a circular orbit to an elliptical orbit and back to a circular orbit every 96,000 years. And when the Earth's orbit is elliptical, on average, the Earth gets more energy from the Sun than when the Earth's orbit is circular. And consequently, the Earth's climate is warmer when we have an elliptical orbit. That's called orbital eccentricity. Second way the Earth's orbit around the Sun changes is this. It's called axial tilt. And this change, this cycle, takes around 41,000 years. The Earth orbits the Sun, but the Earth also rotates around its axis, which is an invisible line going from the North Pole to the South Pole, almost directly from the North Pole to the South Pole, but not quite. The Earth is in fact tilted on its axis. And the amount that the Earth tilts on its axis changes during cycles of 41,000 years. And here's why this is important. The minimum distance between the Earth being completely vertical facing the Sun is 22.1 degrees angle. This line here to completely vertical. And the maximum distance is 24.5 degrees. This line here. Now, big idea. When the Earth, or I should say, if the Earth is vertically facing the Sun directly like this, if there is no change in the angle to the Sun, then there will be no seasons on Earth. Places on Earth get their seasons because the angle of that place compared to the Sun changes throughout the year. And that angle changes because the Earth is tilted on its axis like this. So, for example, the UK. When the UK is tilted towards the Sun, we have summer, because the UK is more directly facing the Sun, so it gets more heat. However, 6 months later in winter, the UK is angled away from the Sun, like this. And so the sunlight is spread over a larger area because the UK is angled away, and so the UK is colder. These seasons would not happen anywhere on Earth if the Earth was directly vertical like this, and if the tilt of the Earth never changed. That's important for the following reason. When the Earth has the smallest possible tilt of 22.1 degrees, this gives a milder summer temperature in the northern hemisphere. What does that mean? It means a colder summer temperature. Why? Because the northern hemisphere, at the minimum possible tilt of 22.1 degrees, is not angled so directly towards the Sun. And so the northern hemisphere will be colder in summer than it would be at 24.5 degrees. Because the northern hemisphere is colder in summer at 22.1 degrees, the North Pole around here, within the Arctic Circle here, remains freezing for 12 months of the year when the Earth is at 22.1 degrees. And that means that ice can build up throughout the year. More ice means more sunlight is reflected back to space, because ice reflects sunlight. And the more sunlight that is reflected back to space, the less is absorbed by the ground on Earth and the sea, and so the colder the Earth gets. Consequently, every 41,000 years, the Earth goes from its warmest periods to its coldest periods because the angle of the Earth on its tilt changes from the minimum to the maximum period. During the minimum angle, the Earth is coldest because the northern hemisphere is coldest in the summer, meaning there's most ice possible to grow in the northern hemisphere. when the angle's the biggest. The Earth is warmest every 41,000 years because the northern hemisphere is pointed most directly towards the sun in summer, and so much more ice melts, and consequently less ice means less sunlight is reflected, more sunlight is absorbed, the planet gets warmer. So far we have two orbital changes, orbital eccentricity and axial tilt, that both affect the temperature on Earth in different ways. One of these takes 96,000 year cycles, the other one takes 41,000 year cycles. Finally, the most complex but the least important in terms of the Earth's climate is called precession. If you've ever used a spinning top and watched it spin around, when it slows down you'll notice it starts to wobble. The same thing happens to Earth on its axis. The Earth wobbles. And this process of wobbling from left to right takes 23,000 years. Now, big idea. When the Earth's wobble causes the northern hemisphere to point towards the sun in summer more, this makes Earth's northern hemisphere summers warmer. However, when the Earth's wobble, or precession, causes the northern hemisphere to face away from the sun in summer, this makes northern hemisphere summers colder, and consequently ice grows, and so you have a colder climate. These three processes, eccentricity, axial tilt, and precession, all affect the temperature on Earth because they affect, in the case of eccentricity, the amount of sunlight the whole of the Earth receives, and in the case of axial tilt and precession, they affect the amount of sunlight that the northern hemisphere receives, and so the amount of ice that can grow in the northern hemisphere. And they take many thousands of years, as you can see here, to go from one to the other. Let me show you how this affects the climate on Earth. Subtitle, underline it. The most important of these orbital changes is thought to be orbital eccentricity, which, as you know now, takes 96,000 years to go from a circle to an elliptical orbit and back. Here is a graph of the Earth's temperature change over the last 450,000 years. What do you notice? Well, when the Earth has an elliptical orbit, we get our warmer periods. As you can see, it takes about 100,000 years between each warmer period, almost perfectly matching orbital eccentricity. These warmer periods are called interglacial periods. By contrast, when the Earth has a circular orbit, we get our glacial periods, which are the colder periods in Earth's climate, as you can see here, again, happening every 96,000 years or so. This pattern over the last 450,000 years almost perfectly matches the cycle of orbital eccentricity and provides us with evidence that orbital change affects Earth's climate. However, as you can see, this process is very slow, taking many hundreds of thousands of years to go from warm to cold to warm to cold. And consequently, this process cannot explain the sudden and very rapid change in temperatures that we are seeing today. Subtitle. Underline it, please, with a ruler. What are sunspots and how can they cause climate change? Well, here's a photo taken by a satellite telescope, and it's a photo of the sun. But the sun has, of course, been darkened to such an extent using the camera that you can see that the surface of the sun does not all look the same. In fact, there are these darker spots on the surface. These are called sunspots, and they are slightly cooler areas of the sun's surface. Now, I'm going to tell you something that might sound confusing. When the sun has more cooler areas on its surface, sunspots, it actually releases more heat. Because of various processes happening within the sun, the increased number of sunspots causes the sun to release more heat, leading the Earth to be warmer, because that heat travels towards Earth, warming up Earth's atmosphere. The sun goes from a period of maximum sunspots, maximum heat, to minimum sunspots, minimum heat, every 11 years. So in 11-year cycles. And how does that affect Earth's climate? Here's a graph showing the temperature on Earth and the sun's energy being released since 1880. The blue line shows you that the amount of sunspots has increased and decreased roughly every 11 years over the last 140 years. And as you can see, the temperature on Earth has very closely matched the amount of sunspots. And so we can see that the changes in the sunspots over these 11-year cycles affect Earth's climate. However, this process was true up until about 1960, when about 10% of Earth's temperature changes were explained by the changes in temperature of the sun, the amount of sunspots. After 1960, what you can see is that the pattern of sunspots has not changed. The cycle goes up and down roughly every 11 years. But the temperature on Earth has just continued to go straight up, and now it no longer follows the pattern of sunspots. Something has happened since 1960 that means that the Earth's climate is no longer following the amount of energy released by the sun. There's something else happening. Next lesson we'll find out what that is. Time to assess learning. Write 1 to 15. Use the words in the boxes to complete the gaps. Go for it, then we'll mark our answers. So number 1, orbit. 2, elliptical. Elliptical means not circular, the one where it was widest. 3, warmer climates. 4, cooler. 5, axis. 6, hemisphere. 7, 22.1. 8, 24.5. 9, precession. 10, warms up. 11, warmest. 12, coolest. 13, sunspots. 14, 10%. 15, have not. Give yourselves a mark out of 15. If you got 13 or more, you've really understood these. Any questions that you got wrong, please correct them in green pen. Right, time to embed learning now. I'm going to show you 2 questions. Answer the questions from memory ideally, and then mark your answers in green pen. Make sure you add any corrections. Consider the keywords that you need to use in this question, such as eccentricity and glacial and interglacial. Give numbers if you can. Give numbers for this as well. Okay, number 1. You should have had these 4 points. Make sure that you add in green pen any parts that you missed. Ensure also that you have all these underlined words and phrases that I've got here. And 2, sunspots. Make sure you've got the word fluctuates and 11 years. Give yourselves a mark out of 8. If you got 7 or 8, fantastic. Any less, make sure that you go back and watch this explanation in a week's time and complete these questions again from memory. From this lesson, write 2 questions. Answer them from memory, and then in a week's time test yourselves on them to see if you've remembered them. Thank you so much for joining me this lesson on a really complex idea called the Milankovitch Cycles, which helped to explain climate change in the past. But next lesson we're going to be showing how human activity is causing climate change now, much more than these natural causes. Join me then.